Okay, maybe wait a minute for people to come. Okay, let's get started. So my name is Matthew, and this is my email. So I mean, unless it's personal, I suggest if it's a math question. So right now Piazza is filled with technicality questions since Canvas is new and stuff. But see, the syllabus does say like attendance is mandatory, right? But there's definitely mandatory in quizzes, as you'll see later. Yeah, I mean, like for the non-quiz days, like I think the professor cares that you come, right? So she did say in the syllabus it's mandatory. So I don't know if she's gonna dock you off points for like not coming. I mean, I won't, but like maybe the professor might. Okay, so but definitely on quiz days you should come. So no, if you have a question, I suggest you post it on Piazza. Yeah, because not only I can answer, other TAs and more importantly, other students can answer. Right. So Piazza right now is filled with technical questions because it's the beginning. But you'll see later on, Piazza is gonna be, it's gonna be for like math 2B, actual math 2B questions. So yeah. Okay. So suggest you ask on Piazza. Okay, so more important thing is like office hours, right? So for those of you who didn't take 2A or skipped it, right? There's something called tutoring center. This is different from office hours in a way. So it's like free office hours, but it's ongoing. So it's like, let me just say it's 9 a.m. to like 4 p.m. ish every day, every weekday. Sorry. I guess that's sort of assumed. But so the nice thing about this is like, in your other classes, right? Like if the TA and professor has office hours that like, where you have class, you're sort of like, you're out of options, right? For help. But for math 2A, 2B, it's different, right? Like this thing is open from morning to like, almost early evening, right? So there's bound to be a time, and it's open every day. So there's bound to be a time where, you're free. And then like you can just go in and ask questions. It's free, right? There's you don't pay. So the reason we could do this is because there are let me just say lots of math 2A/2B TAs. And what happens is we take shifts here. Yeah. So my shift, I mean, you don't have to come during my shift, but it's Tuesday, Thursday after this discussion. So 10 to 11 a.m. But if this doesn't work for you, again, it's open 9 a.m. to 4 p.m. It's just that maybe when you go, it won't be me. It will be like another TA. Yeah. And you can ask them on 2B, right? So even if it's a math 2A TA, you can ask them math 2B questions. Yeah. So it's, we're supposed to know all this regardless of whether we're math 2A or 2B TAs. So yeah, so this is the nice thing about 2A, 2B. It's like you sort of have like free office hours the whole day. Along with, whenever the professor's office hours are. And here, but no, we can only answer your, we're told to only answer 2A, 2B questions. Yeah. So like, I mean, even if I know like math 3A, you technically don't go there to ask for math 3A help. So, okay. Uh, yeah. So the Turing Center, the link should be on the Canvas, but you can just look it up on the math website. So next thing, quizzes. So this is important, yeah, because you know the professor actually I know like she actually gives zeros if you don't follow this. So it's taken at end of discussion. I would say like the last 15 minutes ish. Yeah. So it's still during discussion. Yeah, it's not like after discussion. And what happens is it's posted on Canvas, the discussion Canvas page. Yeah. And what happens is you would just take it online, but you have to remain in Zoom. Yeah. So basically, you remain in Zoom with video on. Yeah, so if your video is off, I heard the professor does give you zero. So they make sure your video is on and you are in Zoom. Yeah. So there is Zoom features that checks whether you are actually in the Zoom meeting. So don't just, don't attend and just take the quiz anyway. I mean, it's possible, right? You could take the quiz without coming here, right? Because it's on Canvas. But like there are ways to check whether you are here or not. There are like special Zoom features, so do not do that. And yeah, so make sure your video's on. Basically, I will just be watching you. Yeah, so I'll be watching I mean, just checking for cheating. Yeah. I will proctor. I mean, really, the whole point with video on, I should be able to see your face slash hands. If you're too close, maybe if I don't see it, just push the computer back a bit. Maybe you're too close to the computer. Um, you know, this is just to check whether you're not texting someone or like you're not posting answers on WeChat, yeah, stuff like that. So it's not really you can certainly write stuff, right? So if you need to do scratch paper, I'm not gonna tell you like don't use scratch paper, right? I mean, I'm just checking, you don't use your phone, stuff like that. Just to keep a non-cheating environment. Everyone clear on this? Yeah, I set this to be recorded on cloud. So if you go to Zoom tab, it should be in cloud recordings, if I'm not mistaken. Okay. So is everyone clear? So let me just say the final, and midterm, final, and quizzes. I was told by the professor, like, I don't need to grade. So by that, I'm assuming that, Canvas grades it, right? So since Canvas grades it, I'm assuming there's like, this is just me, but I'm assuming that there's no free response. There's no short answer. Because if it's short answer, we as humans have to grade it, right? Like there's no way a machine can grade like the free answer part. So I'm guessing, yeah, I'm guessing the quizzes, midterm, and final is not just multiple choice, but like true, false, matching, multiple answer, right? Stuff like that. So something where like Canvas can just grade it. I'm assuming it'll be like that. And then you have WebAssign. So this is online homework. So this is homework. This is also graded immediately, right? So nothing there. So the only thing I grade is the written homework. Yeah. So I grade this. Yeah. So written homework is fairly simple, right? So when she does post it, or if she has posted already, she would post the questions. You just write it, right? Submit it as a single PDF. Yeah. Don't just take like 10 screenshots and then just submit all 10 screenshots. Submit it as a single PDF. And then like One set of camera. I mean, I like I said, I just need to see your face and hands. That's about it. Like just to like make sure you're not texting someone or something like that. Yeah, so written homework is basically you just submit it, you write it, upload before the due date. Yeah, shouldn't be that bad. Okay. Yeah. As long as I see your face and hands. Yeah. Okay. Any questions about this? So yeah, so make sure you know have actually have a camera. I guess that's the most important thing. But you have a camera, make sure you uh midterm and final from the syllabus, I believe it's like in the lecture, and I think it's done using Respondus. Yeah. I mean, so I'm not monitoring how close you are to the computer, right? So, so you can certainly push your laptop back. Like, it doesn't really matter. Uh, can't see your, so see the grade. It's a bit misleading, right? Because on the discussion Canvas page, right? So discussion Canvas page. This thing will have your like written homework grade, right? Sorry, I should put, yeah. So, and since the quizzes are posted in the discussion page, your quiz grades will be there, right? But then like I'm not sure where the WebAssign grades go, but the midterm and final grades are in like the lecture Canvas page. So you know what I mean? So it's kind of hard to like tell you your grade because you know until the professor combines these to so like Microsoft Excel and starts calculating. I mean, I guess you can manually do it yourself, right? But like, yeah, and she normally does that at the end, right? So like, it's hard to like just combine grade books all the time. So she normally waits until the end. Uh, uh, I think no, I think I could publish your written homework grades and quiz grades. It's just that it's hard to know your overall grade without calculating, right? Without like doing tons of math. Okay. Uh, if any of that changes, I'll let you know. Okay, can we move on to math 2B, or do you have any other questions in terms of how things will work? Okay, so let's start math 2B. So antiderivative of f of a function f, yeah. So we are going backwards. So basically, we are asking derivative of what gives f. Yeah. So in math 2A, you went forwards, right? Like I gave you f and I asked you to find the derivative. Here is the opposite. I give you f and I ask you derivative of what gives that. So let's do a simple example. Antiderivative of just the function f of x is x, yeah? So derivative of what gives x? Can anyone tell me? So this, yeah, 1/2 x squared. But it's not just that. What else? mean, you could pick your favorite number, right? Like 1/2 x squared plus 5, 1/2 x squared plus pi. And it's based off the fact that derivative of numbers of constants is 0, right? So we normally just write 1/2 x squared plus c to account for all of it, right? So you see, this already tells you it's different from derivative, right? Because the antiderivative is a family of functions, right? It's not just one specific one, right? I'm sure if I told you like if derivative of sine is cosine, you're not gonna say, what if there's another derivative, right? Like what if, right? Derivatives are in a way you could think of it as like unique, right? If I tell you derivative of sine, it's cosine. It can't be anything else. But antiderivative is different. It could be like tons of things, right? It's a family of functions, if you like. So, okay, with that in mind, let's go over some easy antiderivatives, right? So, antiderivative of, say, x to the n, what is that? Well, here you could sort of generalize, right? Like you could say, what did I do when I took derivative? So it's n x to the n minus 1, right? So if I'm going backwards, you should think, let's just do the opposite, right? And instead of subtracting 1, I add 1, and instead of multiplying, I divide. Yeah, and you can always check that whether your answer is correct by taking derivative, right? So to check whether your answer is correct, you take derivative of this, you better get this, right? So if you want to check, let's take derivative. Derivative of c is 0, it's a constant. So using the power rule, it's n plus 1 x to the n plus 1 minus 1. So I'm using this rule now over n plus 1. The n plus 1 cancel, and I get x to the n. Yeah, so this is for n not equal to minus 1, right? Because if n was minus 1, I would be dividing by 0 here, right? Negative 1 plus 1 is 0. And we don't want that. So you see the antiderivative of x to the n is x to the n plus 1 over n plus 1 plus c, if you like. So what about the case where it is minus 1? What is the antiderivative of this? No answer. Okay, so let's make it easier. Another way to write x to the negative 1 is 1 over x. Maybe you're more used to that. So derivative of what gives 1 over x? Good. Yeah. So, but it's not exactly ln. It's actually you need absolute value. Yeah. So the reason for this is the domains don't a priori, they don't completely overlap, right? Because here certainly x equals -5 is a valid thing to plug in, right? Like you get -1/5 if I plug in -5, right? So you can certainly plug in negative numbers to 1 over x, right? I mean, you just can't plug in 0. But you see, if I didn't have the absolute value, natural log cannot take in -5, right? Like you can't log a negative number, if you remember. So that's sort of why you need an absolute value. So like, it matches on the domain. Okay. With that said, let's do some examples now. Yeah. Using this power rule. So find general antiderivative. So let's start off easy. Yeah. F of x is 6 plus 3x squared minus 1 over x squared. So just like how derivative of sum is sum of derivatives, right? So derivative of like a plus b, I could just take derivative of a and then add derivative of b. Right? I could do it term by term. So same thing here. Let's do it term by term. So what is antiderivative of 6? Yeah, so this is pretty no-brainer, right? I mean, you just brute force it, but you could actually use this, right? Because 6 is 6x to the 0. Everyone agree? Because x to the 0 is 1, right? So in theory, you could say this is 6x to the 0 plus 1 over 0 plus 1, which is 6x, right? But, if you want to, use the rule. All right, so same thing here, right? Plus, so antiderivative of x squared, what is it? It's x to the 2 plus 1 over 2 plus 1 plus c, right? So it's 3 times x cubed over 3, right? Now, this one is a bit harder, right? But what is the antiderivative of 1 over x squared? No. So yeah, I mean that's a good mistake to have, right? So this thing, right? If you claim is this, let's use math 2a and take derivative, right? So if I take derivative, I better get negative 1 over x squared, right? So here, this thing is chain rule, right? If you remember from math 2a, it's 1 over x squared times derivative of x squared, right? Which is 2x. So I get 2 over x. So this is certainly not ln of x squared, right? So again, just because the antiderivative of this is ln x, it doesn't mean that like whenever you have a denominator, it just goes to this, right? It just it's just not true, right? You can't just so you have to use the rule very specifically. So it's only ln x when you have a 1 over x. So is it 1 over, yeah, it is 1 over x, but let's sort of see why. Yeah. So whenever you do this, I suggest you change everything to powers, yeah? Because we have a rule for x to some power. So how do I write 1 over x squared as x to some power? This is equal to what? Is equal to x to what power? -2. Good. And now we could apply the rule. Again, the rule works for everything but -1, right? So what is that? X, so it's negative x to the -1 plus c, which is negative, if you like, -1 over x plus c, right? So negative negative becomes positive, right? So 1 over x plus c. Yeah. So technically, this one gives like a plus c1, this one gives a plus c2, this one gives a plus c3, but we'll just combine the c1, c2, c3 to make it just one c. Okay. Everyone clear on this? So general rule of thumb, if you see powers, right, always convert to x to some power. And then apply power rule. Makes stuff much easier. Okay. So same type of question. Let's go a little harder. Cosine of x plus e to the x plus e plus cube root of x. Okay. What is derivative of cosine? I mean antiderivative of cosine. Yeah. So again, you ask derivative of what gives cosine, right? So you're working backwards. Now, derivative of what gives e to the x? This one's easiest because derivative of e to the x is e to the x. So antiderivative of e to the x is e to the x. What about this? Good, good. do not say E, yeah? If you say E, you're making a, a mistake. This is actually EX, yeah? So make sure you differentiate between e to the x and e, because these are two different functions, right? The function e to the x, it looks like this, right? I don't know, just graphically looks something like this. How does a function e look like? I mean, e is just a number, right? It's like 2.7 something, so it's like a flat line, right? And like, so this is a number. It doesn't really depend on x, right? It's the same thing for every x. This thing depends on x, right? When x is 1, it's e. When x is 2, it's e squared. So it depends on x, right? So for numbers, like we did in the problem before, right? You told me the antiderivative of 6 was 6x, right? So same idea here. Antiderivative of e is just a number, right? If you like, antiderivative of 2 is 2x, right? Of pi is pi x, yeah? So antiderivative of e is ex. Yeah. Everyone good with that? So make sure you know the difference here, yeah? I mean, say it and like it doesn't matter like the power. I could have made this like e to the 1,000, right? The antiderivative e to the 1,000 is still some number, so it's still just this, right? So okay, last one. What's antiderivative of cube root of x? No, that does not look right. Yeah. So again, let's take it slowly. So since we just started, so let's again rewrite this as a power. Yeah. Cube root of x is x to the what power? Good. And then we just use power rule. Need the power rule for antiderivatives. Yeah, so I guess some books call this power rule. Kind of like how we have power rule for derivative. This is called power rule for antiderivatives. Let's see. So this is what? 3/4 x to the 4/3, right? Okay, so this is your answer. Everyone clear on this? Nothing too bad. So right now, right, we can only do things that you know derivative of, right? I mean, something that's fairly simple, right? So later on, we'll learn techniques to find more antiderivatives because, I mean, I could let you think about it, right? I didn't tell the other classes, but like you could just imagine like what's antiderivatives. Something as simple as this is actually pretty hard. Yeah, like you could think for a long time, but like it seems like it's very hard to figure out derivative of what gives this, right? Like going forwards is easier in a way because going forwards you learn the rules for whatever, right? If I give you a function, a simple function, you know the derivative of it, and then if you do any operation, you just apply the rule, right? Like if you're multiplying, it's product rule. If you're I don't know, dividing by two simple functions is quotient rule. If you're composing, it's chain rule, right? So you sort of know, you just go with whatever rule works, right? Here, it's not that simple. So okay, yeah, but for now, for now, the antiderivatives are pretty simple. Yeah. So let's do something different. So find antiderivative. This is anti. The div f of f satisfying certain conditions. So f of x is 2e to the x minus 6x. And I want f of 0 to be 1. So let's ignore this for now. Yeah. let's find the general antiderivative, right? With the plus c. So what is antiderivative of 2e to the x? Not a trick question. What's antiderivative to e? Yeah, it's just 2e to the x, right? And what about 6x? So again, power rule. X goes to x to the 1 plus 1 divided by 1 plus 1, right? You think of x as x to the first. Good, 3x squared plus c, right? But now, right, this condition fixes what my c is, right? Because so in general, if they didn't tell me this, the plus c is all I could do, right? But with this, I actually know what my c is, because I know this has to be 1. So 2e to the 0, 0 squared plus c. So I get 1 equals 2. What is e to the 0? 1. Good. Minus 0 plus c. So what is c? C is like negative 1, right? 1 equals 2 plus c. So your final answer is yeah. Yeah, so I think on your homework, you either have find the antiderivative or find the specific one, in which case they have to give you some condition here. Yeah. So let's do one more pertaining to that, right? If I tell you f double prime of theta is sine theta plus cosine theta, and I tell you f of 0 is 3, f prime of 0 is 4. And I tell you to find f. Yeah? Okay. So obviously we're taking antiderivative, right? So question, if I take antiderivative of f double prime, what do I get? Do I get f or do I get f prime? Yeah, right? Because f double prime is derivative, right? So think of antiderivative as canceling out one of the derivatives. So, because you're going backwards, right? So I get f prime of theta. Let's figure out what f prime of theta is then. So what's antiderivative of sine? Negative cosine, good. It's not x, but it's theta. You could put parentheses if you like. I think it's understood. So what's antiderivative of cosine? Good. Sine theta, right? And then plus c. So now, but we know what the c is because they gave us this condition. So f prime of 0 is 4, which is negative cosine of 0. So this is when you need your trig. So what is cosine of 0? 1. Good. What's sine of 0? Good. So c is what? C is 5. Yeah. So f prime of theta is negative cosine of theta plus sine of theta plus 5. And now that I have f prime, if I take antiderivative again, what do I get? Do I get f now? So antiderivative of f prime. Yeah, you get f, right? Good. So let's do this again. What's antiderivative of let's just antiderivative of cosine is sine, right? So it's negative sine. And then antiderivative of sine is negative cosine, right? And what's antiderivative of 5? Yeah, in this case, 5 theta, right? plus, I don't know, you could use C again. We used C before. Let's use a different letter, D. Yeah. So now we have f of 0 is 3 is negative sine of 0 minus cosine of 0 plus 5 times 0 plus d, right? So again, like we said before, sine of 0 is 0, cosine of 0 is 1, so I get negative 1. 5 times 0 is just 0, so this is just plus d. So d is 4. Yeah, so your final answer is f of theta is plus 5 theta plus 4. Everyone clear on this? I mean, it's just the previous question, except you're doing it 2 times instead of 1. Yeah, so for the purposes of the homework, you might get this, but it's really this question, but in a physics way. So if s of t is position at time t, then the derivative, we call that velocity. Yeah. So s prime of t is, if you like, is called v of t. Yeah. I mean, it makes sense, right? Because velocity is like rate, right? So, and derivative is kind of like rate. Yeah. And then s double prime of t, which is the derivative of velocity, we call that acceleration. Yeah. So you might get a problem like this. It's just, the same thing. So normally what they do is they give you acceleration. A of t. And they ask you to find velocity and position. Right? And then they give you like initial velocity or something. And like initial position. Yeah, so I mean, without doing the question, let me just let's walk through how to solve this, right? So if I have a of t, the acceleration, how do I find velocity? How do I find v of t? What do I do to acceleration? Anyone? You take antiderivative, right? Because velocity, derivative velocity is acceleration, right? So I take antiderivative, right? And I will get v of t, right? And normally they would give you initial velocity, right? So what does initial velocity mean? So initial means what? At time what? T equals what? 0, yeah? So they're basically giving you s prime at 0 is something, right? Kind of like this, yeah? And then with that, you can find what the constant is. Okay, so now that you found what the constant is, how would you find position? Yeah, take antiderivative again, right? You have the velocity function. Derivative of position is velocity. So antiderivative of velocity is position, right? And then with this, you get another constant, but normally the problem would give you something like initial position or something, in which case they tell you at 0, at time 0, it's something kind of like here. Yeah, at 0, it's think of f as like position, f prime as velocity, f double prime as acceleration, if you like. And yeah, so it's pretty much this problem sort of, right? Except it's worded in a physics way. Okay, everyone clear on that? So, I mean, they might not give you this. Maybe they tell you at time 1 or something, right? I mean, it doesn't have to be 0. It's just it's 0 here to make calculation easier. So, okay. So, okay. So I'm gonna give you motivation because I think a lot in math 2B gets confusing because you actually don't know why you're learning the things you're learning. So I think it's best if I sort of explain to you why, because right now we're at 4.9, right? I'm gonna tell you 5.1 is about area. So now you're wondering like, why did we just move from like finding antiderivatives to like area? And like, it seems like very, it seems like we're just skipping something, right? We're moving to a completely different topic, right? So let me just, and more importantly, this will also answer why you're wondering like, I know how to go forward. I know how to take derivatives. Like, why on earth should I care about going backwards, right? Like, why do we even care about that? So let me just say, right now, right, for area, you really, the only ones you know are like triangles, right? Maybe like circles, rectangles, maybe if you remember trapezoids, right? But really, like, we only know area of like certain shapes, right? Like this is pi r squared, right? Length times width, 1/2 base times height, right? So now if I give you something, the problem is, what if I give you really it's only the circle that we know, right? That's curvy, right? So this bad picture, but 0 to 1. If I ask you to find the area of this, you would struggle without, if you haven't learned math 2B yet, because this thing is kind of like curvy, right? It's hard to find the area, right? Like if it's flat, you just divide it to like rectangles or something, right? So let me give you an intuition that let me just say the idea is antiderivatives tell you area. Yeah. So let me just convince you of a few examples, and then you'll be like, whoa, that's cool. Let's take the line y equals x, and let's just consider it from 0 to 1. Yeah. So from 0 to 1, I have this triangle, right? This is 1, right? Because it's y equals x. And I want to find the area of this triangle. What is the formula for, so this is length 1 with length, base is 1, height is 1. So what's the area? It's 1/2 base times height. So it's 1/2. This is 1/2, right? The area of this triangle. Now, let me ask you, what is the antiderivative of x? Just take c to be 0 for now. So just take the c equals 0, 1. So what is antiderivative of x? Anyone? No, antiderivative of x. A derivative of x is 1, right? I'm asking for antiderivative, right? It's 1/2 x squared. So what I'm going to do is I'm going to evaluate at wherever the endpoints are, and then I'm going to subtract them. Minus 1/2 0 squared. And you're going to see that you get a half, and these two match, yeah? Now, let's do another example. Let's take y equals 3, yeah? And let's consider this rectangle from 0 to 2, yeah? And I want the area of this rectangle. So let's do the antiderivative case first. What is antiderivative of 3? This should be easy. What is antiderivative of the function 3? Right, and I'm going from 2 to 0, 2 to 0, 0 to 2, right? So I go 3 times 2 minus 3 times 0. And that's 6, right? Now let's check it. This rectangle has width or length 2, if you like, and the height is 3. So what's the area of this rectangle? Yeah. And again, they match. Yeah. And what you're going to see is, I'll tell you now, the antiderivative of x squared, you know this, is 1/3 x cubed. and I'm going from 1 to 0. So you will see that this I'm telling you it's true, we don't know yet, right? But uh, the area here is actually 1/3. But the idea is antiderivatives sort of tell you area, right? And now, so basically, if you know the antiderivative of the function, you know the area. Now, why is this important? Is, I guess, let me just ask you. Well, I mean, I guess one application maybe some of you might use if you're in physics or something, right? Is what's the three-dimensional word for area? Anyone have an idea? Yeah, volume, right? So yeah, so if you think about it, like, so if you like maybe like Arrowhead, right? Like they give you like a water bottle. How do you think Arrowhead knows like how many liters this thing is, right? They actually they actually find antiderivative of the circle function, and then they go from like here to here. Yeah. So like anything that is about volume, and like area, it's all antiderivatives. Later on you'll see we call that integral, but it's all antiderivatives on how they figure out, like how many liter is in the water bottle, right? You would take antiderivative of the circle, or like the semicircle function. Yeah, so that's sort of the intuition. Hopefully that helps. Yeah, so next time we will go into area under curves. Yeah, we'll start that, and then we'll get deeper and deeper. Yeah. Okay. If no one else has questions, I will see you all Thursday then.